Module 11, Concepts of Population, Sample and Confidence Interval, Section 2, Confidence Interval of Standard Deviation, Binomial Distribution and Poisson Distribution. Confidence interval can be used for most of the statistical operations. It's not really limited to the standard deviations alone, but you can also go for the difference between two group means or a proportion or the rate of the proportions, or you can go for a best fit linear regression line. You can even calculate the confidence interval of that line, and the rate of the median survival time and so on. So, the confidence interval tells you how precisely you have estimated that estimate, whatever the estimate that you are doing that from the sample as an estimate of the population estimate, So, how the sample is differing from the population, the true population, for example, mean, that we have already seen that in our earlier section. Confidence interval of the standard deviation can be calculated by some formula. So, it is in the Excel, this is a formula that is kind of like a tricky formula, but it can still be used for it. So, if it is alpha is 0.05 and for the 95% confidence interval, so you can use it as 0.01 for 99% or 0.05 for 95% confidence level. So, you can substitute that alpha into the following equation. So, then it will return two values. So, one is lower limit and the upper limit. So, you see the standard deviation itself is an estimate, right, plus minus some standard deviation. Now, this is plus minus that value. So, it is actually an error bar, the standard deviation. So, each error bar, the error bar will have a positive and negative value. Now, positive head of the error bar still again will contain the another error. So, negative will have another error. So, it is very interesting that confidence interval of the standard deviation can be computed by the formula, and the formula, as you can see, depends upon chi-square inverted distribution. So, it is also a very interesting formula that you can use it, or you can use it in an online calculator by the GraphPad itself is having a quick calc. So, you can click on that link and then you just have to input the values of the standard deviation and n, that is the sample size. For example, in our earlier marks data, if you input, then you will see that, so the 95% SD is 3.81 to 6.80. So, this is that. So, that means that you can actually calculate it, each of the standard deviation will be plus minus of that value you can calculate. There will be total 4 limits in it. 2 will be for the upper limit and 2 will be for the lower limit. Coming next is confidence interval of the counted data, that is the Poisson distribution, you see. So, counted data like number of mutations in a stretch of DNA or the number of raisins in the laddu follow Poisson distribution, or number of persons dead in an island, that all follow the Poisson distribution if it is random. So, confidence interval can be determined from the count alone. You see, just we need to know how much is the count, the number of the events happen. For example, the count is 66, the death in an island, then you can say that the count is 66. So, just with the count you can calculate the upper limit and lower limit, the confidence interval of that count. So, for example, it is a very simple problem. After dissecting 10 laddus, so you take laddu, the sweet laddu, so you dissect 10 laddus, a total of 25 raisins were found. How can you calculate 95% confidence interval of and as well as number of raisins per laddu? So, the mean of the number of raisins per laddu you can calculate, and its 95% confidence interval, that is a count data. How can you do that? Of course, you can use one of the online calculator like the stat pages that I have hyperlinked it. So, you can click on it and all you need to do is just input the count. So, the count has to be 25 here. It is not that after averaging out, so the 10 laddu is 25, so per laddu it is 2.5, then you input the 2.5, that is wrong. So, the input data has to be the empirical data, the data that you observed. So, you just input the data and then you can calculate the confidence interval of that one. So, if the count is more than 25, so then the approximation is 95% CI approximation is count minus 1.96 into root c, that is the lower limit, to count plus 1.96 into root c. So, we can use this formula for our Laddu example. Let us do that on the board. So, let us calculate the confidence interval of the count data, that is our Laddu example. So, what we know already is that we have 10 Laddus, and from 10 Laddu after dissecting we got 25 raisins. So, it is raisins. Alright, so we have 25 raisins. So, this is our C, that is nothing but count. So, an approximation if it is 25 and above is that the formula goes on like this: Ci is equal to C minus 1.96 root C to C plus 1.96 root C. So, all we need to know is this C. So, the C here is 25, just substitute into this formula. So, let us substitute and see that C is 25. So, 25 minus 1.96 root 25 to, again 25, here it is plus 1.96 into root 25. So, if you calculate this one, this is going to be this will be the answer is going to be 15.2 to 34.8. So, this is our the confidence interval of this 25. So, just by knowing this 25 you will get 15.2 is the lower limit and 34.8 is the upper limit. Of course, you can make it in a graphical manner as well. So, if this one is 25, so this is the lower limit is going to be at 15.2 while the upper limit is going to be at 34.8. So, it is a very convenient way to do this one. So, as you know, we have dissected 10 Laddus, so to get 2.5 raisins. So, if you want to know the mean raisins per Laddu, it is 2.5. So, 25 raisins upon 10 is equal to 2.5. So, 2.5 raisin per Laddu, but this value 2.5 also need the confidence level. So, how do you calculate the confidence level? So, these are based upon 10. So, these limits you just have to divide with 10 to get because it is 10. So, just divide into divide by the 10. So, 15.2 divided by 10 is equal to 1.522. This divided by 10 is equal to 3.48. So, this is the right method to calculate it. So, instead of doing like this one, so if you do this first, so 25 by 10 is 2.5 and use this 2.5 as the count, that is C, this is wrong. The answer is going to be wrong. So, always base your calculation from the observation. So, the count has to be the observed value. So, this is how to calculate the confidence interval of the count data. Let us see yet another example here. So, in this case, there were 36 mutations in a stretch of genome containing 10,000 sites. So, average mutations per site with 95% CI. So, you have to calculate the average mutations per site with the 95% CI. So, of course, the average calculation is very simple, that is 36 out of 10,000. So, it is just that 36 divided by 10,000. But as I told you earlier, 95% CI you have to calculate on the real observed frequency. So, here it is 36 mutation, that is the count is 36. So, you have to base your calculation on the 36, not the converted value. So, the formula is, as I told you, is C plus 1.96 root C to C minus 1.96 root C. So, if you solve it, you are going to get 24.23 to 47.76. So, average mutation is 0.0036. So, CI per site is at these the confidence limits each divided by the 10,000. So, that is what the observation. So, you can, if you do that, it is 0.0024 to 0.0047. So, you can do this all this work in GraphPad Prism Quick Calc or a number of online based calculators available, or you can you can also do that in manually as well. So as I told you, one of the common mistake is that when using the Poisson distribution to calculate the confidence interval, you must base the calculation on the actual number of the objects or the events counted, that is C. Any normalization should be done after the confidence interval is computed. For example, in our earlier problem, don't take the average raisins per laddu, that is 2.5 as a count. And so in that case, the confidence interval would have been 0.6 to 7.2. See, it's totally wrong answer. So you have to base that on the empirical number of the count that you have to done that. So finally, divide the CI with the number of observations, that is 10, to get CI per event. So 1.6 to 3.6. So that is the real CI of that one. Now let us know how to calculate the confidence interval of the binomial distribution. See, the binomial distribution is a probabilistic distribution that is very important to calculate the proportions in a population. So that kind of problems are quite often occurring in the biological sciences. So proportion of, for example, proportion of monoecious plants in a population, or in a quadrat of a population, or proportion of an allele or a genotype in a population. So that kind of problems often come in population genetics. Proportion of students who pass the biostatistics, or proportion of H out of 10 coin flips. So what is the proportion of head out of 10 coin flips? So all these things you can use using the modified Waltz formula as displayed on the screen. So this is the manual calculation of the binomial distribution. You can also do this using using any number of the calculators available. So this modified Waltz formula has got two parts. So first part is to calculate the P prime. So the P prime is nothing but number of success, that is S plus 2, divided by total number of observations plus 4. So S plus 2 by N plus 4 is the calculation of the P prime, the proportions. So the next is that P prime, you have to substitute that with the P prime minus 1.96 root P prime into 1 minus P prime divided by N plus 4. 2 P prime multiplied by 1.96, so P prime plus, so first is minus, now here becomes plus 1.96 root P prime multiplied by 1 minus P prime divided by N plus 4. So that is looks like a bit complicated, but it's not at all complicated. It's a very simple formula by the Waltz. So let us see one example here. 45 out of 100 neonatal birth in civil hospital in Bathinda in Punjab were females. So calculate 95% CI of this the value. So 45 out of 100, so it's a proportion, so it is a binomial distribution. So how will you calculate it? So sample proportion is basically 0.45, so that is what the proportion is. Then 95% CI you can calculate either manually or using any number of the calculators. So if you do that with the online calculator, you are going to get 0.35 to 0.55. So then what is that meaning of this confidence interval of the proportion? So that means that there is a 95% chance that this confidence interval contains the true population proportion. So we don't know, is it true population proportion? The population is that the entire the birth rate of the state Punjab. We only have 100 samples, so that the estimate is, it might be very different from that of the true population. So we are actually making the error level of the sample proportion estimation by using this method. So what is the assumption of calculation of the confidence interval for the proportion? Assumption is that random and independent events and accurate data. For example, in that neonatal case, you should never use only the twins data. Twins should be removed, and also it should be from different places. It should be from one hospital alone. It should be from randomized sampling has to be approached in that way. So let us do this one using our modified Waltz method manually, and let us see how to do that. So let us calculate the confidence interval of that particular problem. So the problem was that 45 out of 100 were females. So how to calculate the confidence interval of this proportion here? So first of all, let us write the formula here. So the first is the P prime. P prime is equal to S plus 2 divided by N plus 4. So that is the P prime. So the first step is to calculate the P prime. So the next step will be to calculate the confidence interval. So Ci is equal to P prime minus the width. The width is 1.96 multiplied by root of P prime multiplied by 1 minus P prime divided by N plus 4 2. So the same thing, only difference is that it will be, instead of minus, it will be plus. So let us write down P prime plus 1.96 multiplied by root P prime into 1 minus P prime divided by N plus 4. So first step is to calculate the P prime. So let us do that first. So here it is success plus 2 divided by total plus 4. Success is 45. So this is very straightforward. That is 45 plus 2 divided by 100 plus 4. So that answer is going to be 0.45. So this is the P prime. Next step is substitute that into this equation. So let us first calculate this width of the confidence interval. So the width is to calculate as 1.96 multiplied by root of P prime into 1 minus P prime. So substituting P prime with 0.45. So this is going to be 0.45 multiplied by 1 minus 0.45. That is what here, P prime into 1 minus P prime divided by 104. That is what, this 10 plus 4. See, N plus 4 is 104. So if you solve it, so this one is the width of the confidence interval. So it is W is equal to, width is equal to 0.096. So the width is, it extends to the both directions. So always the confidence interval will have the width. So that plus or minus that whatever the estimate that you are looking. Here the estimate is the proportion. As you can see in this formula, it is P prime minus the width to P prime plus the width. So the first is to calculate the width. So we have already calculated the width. Next is that we already know the P prime is 0.45. So let us actually plug into this equation. P prime is 0.45 minus the width. So the whole stuff is called width. So let me highlight it. The whole, this one is known as the width, W, and this is what we just calculated here. The width is 0.096. So 0.45 minus 0.096. This is one limit, the lower limit, to the upper limit. Upper limit is 0.45 plus 0.096. So if you do this one, then the answer is going to be, of course, this is what the limits are here. So if you solve it, 0.45 minus 0.096. So if you solve it, it's going to be 0.354. So 354 2. 0.45 plus 0.096 is nothing but it is 0.546. So these are the limits of this binomial distribution. So if you want to display it in a graphical manner, so this one is your proportion here, the proportion. So proportion of the female, that is nothing but the proportion is it is basically 45. So 45 plus or minus, so that is the P prime here, 45 divided by 100. So it is basically 0.45 is the average, right? So 0.45 plus or minus this value, the width. So you are going to get 0.354 is the lower limit here. This is 0.354, while the upper limit is 0.546. So 0.45 is because of this proportion. This is 45 divided by 100. So that is what how to calculate the confidence interval of the binomial distribution. Now what does this values actually means? So it means that we have only 100 samples, right? So the true population mean, that means that proportion of females in the whole Punjab population remains unknown to us. So only thing that we can estimate is that this 100 is a sample. So this is the limit. So that means that we can say like 95% chance is that the true population mean falls somewhere between these two values. So that means it could be 35.4% of females in Punjab population to 54.6% of females in Punjab population. It can be anywhere. So that means that if I redo the same sampling 100 times, 95% times the population mean will be between the true population mean, which remains unknown, will be between these two estimates. So that also means that 5% time this will not contain the true population mean. That is what the meaning of the confidence interval of the binomial distribution. Let us now consider one more example here. So in this example, out of 10 plants studied, one plant has capital A small a genotype, while the rest had capital A genotype, AA genotype. Calculate the frequency of small a allele with 95% CI. So how can you calculate that? So one of the common mistake in population genetic problem is that you base that based upon 10. So we studied only 10 plants. So you might think that n is 10, but that is incorrect. This is a diploid plant, so the genome, there are it's actually going to be multiplied by 2. So because of course there are actually 2 chromosomes in each genome. So it's paired of the chromosomes. So the total should not be 10, it has to be 20. So in that case, then you can use that 1 upon 20, and then you can calculate the count data. I mean it's a binomial distribution. Then you can calculate on using a calculator, or you can use a modified Waltz method, which I told you, to calculate the exact confidence interval of this data. Let us consider yet another example here. There were a total of 10,000 deaths in an island over a period of 10 days, 100 days. So what is the average death of the island, death per day, and also what is the 95% CI of this average? Please, you can perform this calculation by yourself. You can use any of these online calculators for it, no problem. One of the common mistake that the students make is that never use 100 as the denominator. So usually the students make 100 if it is in a percentage. So should never be based upon it. As I told you earlier also, in the terms of the count, the value should be exactly how much you measured on the field, or the empirical data, the raw data. Any kind of normalization will invalidate it. So one example would be 2 out of 18 giraffes observed in the nature shows albinism. There is a white giraffes. So is it actually, if you convert that into percentage, then 11.11%? So then you calculate that based upon out of 100, it's 11.11 had 11.11 had albinism. That is incorrect way. So you should base your your analysis from the exact data, that is 2 upon 18. So the terms confidence interval, limits and level seemingly similar, but there is actually subtle differences. Confidence interval is a range with lower limit and the upper limit. So as I told you, confidence interval is also an error bar in the chart. So we plot this error bar to indicate level of uncertainty of determining the sample estimate, for example mean. The two values of this confidence interval, so that means the upper value and lower value. So these limits are known as confidence limit. So the confidence limits will be 2, upper limit and the lower limit. So the desired amount of the statistical confidence is known as confidence level. For example, if you want to be very high confidence of your result, you should choose 99% confidence level and generate a 99% confidence interval. So that level is the amount of confidence you are looking in your data. So my advice is that you should always emphasize confidence interval over the p-value, because the p-value, the interpretation is not straightforward, while confidence interval is a lot more easier to comprehend and understand how it works. So the one of the famous statement is that imperfectly understood confidence intervals are more useful and less dangerous than incorrectly understood p-values and hypothesis tests. This is a statement from H.M. Hennig and D.M. Harley in the American Statistics. So the summary is that 95% confidence interval of the standard deviation can be calculated in the MS Excel or using a web based calculator very easily, or through the manual calculation, though it is a bit challenging. 95% CI of the Poisson distribution or the count data can be calculated using the equation C minus 1.96 into root C to C plus 1.96 into root C. 95% of the binomial distribution can be calculated using a modified Waltz equation or easily by a web based calculator. Thank you for watching and have a nice watching experience for the rest of the course. And I hope please contribute onto the discussion forums. Please actively contribute in, because we tend to learn from each other rather than simply just by watching me speaking to you. And also, if you have any doubt, please ask the questions in the discussion forums. I will be happy to help you. And have a nice time. See you again soon.